when we worked on reflections, rotations, and translations, we call those rigid transformations because they don't change size, they don't change shape, they stay the same. Now, trying to interpret me there. Now, when we talk about dilations, we're talking about a different type of transformation that we're going to look at over the next couple of slides. The first thing I want you to write down, if I can get to it, what are some examples of situations in which you might scale up or scale down an image of something? So what's an example of something that you can think of where you scale up or scale down? Yes, Madison.
When you're like designing a house.
Okay, designing a house. How big do you really want the house? Huh?
What's that called?
Architecture.
Architecture. It's not big.
Okay. That might be something. What else? Most of you have scaled down or scaled up something several times today.
The stairs.
I'm not thinking of it in terms of stairs, but there you go. Alex, what are you doing right now? Are you scaling up or scaling down?
Yes, actually.
Well, that was a serious question. I mean, you could have been scaling up or scaling down on your phone.
Scrolling on TikTok. Pictures.
Not pictures. You scale, if you zoom in, if you zoom out. Okay? That's a big time. A lot of you do that several times a day. I was giving Rocky a hard time last hour. I said, I like to scale in to where he's not in pictures anymore. You know, that ruins him. So try to cut him out. I was zooming in on that guy from Van Buren that got crossed over and put down on his hind end last night. I was laughing. So,
the one that went backwards, like when they went backwards, like
number 15.
Did you see number 20? When they were like, yeah, it was so funny.
Oh my God.
All the children were laughing because number 21 on Van Buren had like a stain that was like black on his butt. It looked like he pooped himself. And when he was shooting, he was like, and he was putting his butt up on like this. So.
Okay. All right. Now, next question. When we zoom in and zoom out from a picture or map, what changes and what stays the same? Okay, it's the same thing, it just grows in size. Or it's the same thing and it gets smaller. But basically, does it keep the original picture? Yes. Same thing if you look on Google Maps. If I zoom in on a Google map, nothing changes. The landscape doesn't change. The picture doesn't change. I'm just able to see more. Or if I scroll out, I'm able to see more of a city or more of a state. But things stay the same. Okay? Now, as we continue to dive deeper into this, we've already done this type of work with triangles. What mathematical term did we use to describe that when we had shapes that were bigger or smaller, but they looked the same? What do we call that? Similar. That's what you're about to say, wasn't it, Madison? Similarity. Okay, we've already worked with similarity. If I have a smaller triangle and a bigger triangle and they have the same shape, then the ratios were the same. Those relationships were the same. Okay? Now we're going to look at it from a different point of view, though. We're not going to call it similarity exactly, but we're going to call it by the specific transformation name. We call this, I'm going to go to slide 5. We're not going to do slide 4. The mathematical term for scaling up or down is called dilation. Similar triangles are dilations of each other. That means that they've gotten bigger or they've gotten smaller. So, Johan, where have you heard the word dilation before?
Wait, so we're not going to do number... We're not doing... So we're...
What, Johan?
Eyeballs?
Have you ever had your eyes dilated?
Yeah, that's the...
Yes.
Does anybody know what happens to your eye when they dilate it? Why they call it that?
Because it gets bigger.
They don't really want it to get smaller because when they shine the light in your eye, they want to be able to see in your cornea. So what they're doing is they're paralyzing your eye and keeping it wide open. They're making it big. It's hard to see, but if you walk out in the sunlight, your corneas get smaller to allow less sun to get in. If you ever go in a dark room, have you ever noticed where it takes a few seconds for you to start seeing things?
Yes.
That's because your eyes have dilated to as big as they can to allow as much light in as they can. Okay? That's how dilations work. That's how dilations of your eyes work. So when we say dilations in the mathematical terms, we're talking about things getting bigger and things getting smaller. But it's not that simple, unfortunately, because we need to talk about where it dilates from. Yesterday you did an assignment and I told you to skip over the dilations, but one of the common words in the dilations was it was dilated around the origin. Y'all remember that? Mm-hmm. So we're going to talk about what that means and how that works. Okay? Now to do that today, we're going to use Desmos again. So I need you to click on this link. I need you to put your phones up, please.
Was my hair?
Yes.
Your hair looks good.
Thank you. I didn't do anything special. I did this. Put my hands under water. I do this. And then I get some pomade.
Some what?
Pomade. You never heard of pomade? Put it on my hand. I just do this. Then I'm done. I spend more time on my beard making sure it's combed out than I do my hair.
You should cut off your beard. I want to see what
Oh.
beard and the mustache.
I look horrible. Look like a little kid.
I won't believe it until I see it. If I pass your class with an A this semester, Mr. Harris, if I pass your class with an A this semester, you have to come on the last day to cut out your beard.
Oh, I don't know about that. We'll see. All right. Here's the first dilation we're going to do. We're going to dilate a triangle, ABC, by a factor of 2, and we're going to use the vertex A as our center. Okay? Afterwards, we're going to take a picture of it, and we're going to post it in our notes here. So what I need you to do on Desmos, use the polygon tool and create a triangle ABC just like this. And be sure that you label the sides A, B, and C. If I can click on C. There we go. So I have a triangle. I'm going to dilate this on a scale of 2. So remember, we hit transform. And this time, which transformation am I going to use?
Dilation.
Dilations. Now, it says choose a point as my center. So which point did it tell me to choose? A. My scale factor is already 2, so I don't have to do anything there. But I need to select the objects to apply this transformation to. So I'm going to hold the shift key down.
Wait, what?
Okay. I'm going to select the objects that I need to dilate. So I'm going to hold the shift key down. I'm going to select all the vertices and all the sides where it should look like that. And then once you hit apply, it's going to give me the dilation. Now, I'm not quite done yet because anytime I do a transformation, this is my pre-image. I need to name my image afterwards. So this vertex becomes what? This becomes B prime. And this vertex becomes C prime.
Whoa. What if mine's closer to A prime?
That's fine. I don't know. You wouldn't have an A prime though, Mary. It should go out from the A. This should be out past the B, and this should be out past the C.
Well, we're supposed to say specific.
Yeah, the very first step is picking A.
Okay, I have to read those.
Okay, let me show you one more time. Okay, when I hit transform, notice it says choose a point center.
Wait. Give me 5 seconds.
1, 2.
Okay, transform, dilation, I got it.
Choose point center. So you're going to select what? A. And then it's my scale factor is already 2. Then select the objects. So I'm going to select.
We still select B?
Well, after you've selected the center, you got to select all the points and all the sides. Nico, can you help her out there? And then be sure that you name them.
It's still next to A. I did like that. Please, that is not supposed to be A prime. So it's going wrong. So I'm doing it this correctly. Look, I'm gonna be bigger, man.
Okay. Now, we need to take a picture of this and put this on. Let's talk about some things real quick. Our scale factor is 2. That means this image, this triangle here, is how much bigger than my original?
2 times.
It's 2 times bigger. So AB prime is twice as long as AB. AC prime is twice as long as AC. And C prime B prime is twice as long as CB. It's a perfect magnification by 2.
Nico did it too, and it still came out with A. I said A.
Now, let's go back to this. Now, when we're doing the function notation, okay, remember, it's just as important with the notation as much as it is the picture, because the notation tells us what we're doing. This time we're not using T for transformation. We're going to actually use the word or the letter D. If I dilate point P, it becomes P prime. So to write that in function notation, all I'm going to put is D of P equals P prime. And I think it's already in there for you in the notes. Okay? But this tells me that I'm dilating something. Okay? Now, I want you to hit the back button, go back to your original triangle, and now I want you to dilate triangle ABC using a scale factor of 3 from the vertex B. Okay, so all you're going to do is hit this back button till you get back to the original triangle, just like this. And now I want you to dilate it. You're going to start over. You're going to choose B. My scale factor becomes 3. Now, if your triangle ends up off screen, you might need to move it up a little bit.
Why is mine like that now? I did it wrong. You said A or B?
From point B.
I just saw.
Now, you might have to click on the triangle and drag it up, or you might even have to make it a little bit smaller. You can drag this point down and make the triangle smaller. But be sure that you have enough to see. Now, We scaled this by 3. That means that the triangle, after I'm done, is now how many times bigger than the original? 3 times. Okay, I'm going to show you in just a second. Okay? Now, it's 3 times bigger. So let's go to the next question on the notes. It says, in the dilation, 2 vertices of the triangles have distinct images, A prime and C prime. But the other vertex doesn't seem to be affected. Why does it look like the center of dilation is not affected by the dilation? Why do I not have a B prime? Or why did I not have an A prime on the last one?
From this point on, it does change its shape and it is affected, but it's centered.
Okay.
I agree with him. I agree with him too.
What Tristan said was, because that's the center of dilation, it's there. Am I right? You just can't see it. Is that what you're saying? Here, let me put this in another way even. Let's say AB is 10. What would A prime B prime be? Or A prime B be? Let me say that one more time. I messed up. If AB is 10, then what is A prime B? 30, because it's 3 times as long. If BC is 9, then what would C prime B be? 27. All I'm doing is multiplying by 3. Okay? What's the distance from B, though, to the dilated center? Say it one more time. 0. The distance from B to the new image is 0. And what's 3 times bigger than 0? 0. So it's there. You just don't see it. It's on top of it. When we do dilations, it's literally a distance. And when I set the scale factor, it's literally that much more or that much less. So it's still there. It's just being multiplied by 0. Okay? Now, what happens if we change that center of dilation? Like, again, yesterday, the center of dilation was the origin. So the next slide says, what if we want to dilate a triangle? Does the center of dilation have to be on the triangle? Can it be inside the triangle? Or can it be outside the triangle? Which one? Does the center have to be on the triangle? Can it be inside? Can it be outside? So why?
Because you can't, like, after you dilate it.
Okay. Has to be dilated from what point?
The point of dilation.
So who decides what the point of dilation is, though?
The thing that's dilating.
Who decides what the point of dilation is? What do we do if we want to find out how things work? Let's experiment. Let's do some research. All right. We need to dilate a triangle.
Hey. Didn't do 10?
We just did.
Wait, what'd you put?
What did you put? That's the question.
I just put no, yes, no.
What did you put?
I'm gonna put no.
Okay. Why are you putting no?
Because I heard no.
It doesn't matter.
Okay, so tomorrow when I hear somebody say, boy, it sure is a nice day to go jump off a bridge, I might as well go do it.
Depends on
I'll go do it.
Oh my god, it would be nice to jump off a bridge.
I'll see you later, Neri. I'm going to go jump off a bridge.
I'll go with you.
Why would you say no, Neri? You can't just do things you hear from other people. That's a bad way of doing things in life.
It's a fun way to keep stuff spontaneous.
I don't know if it's fun. I can think of a lot of things I hear that I'm never going to do.
Imagine people are like, cut off your hand. Okay.
What?
You got to understand, I have 150 kids during the day. I hear a lot of things. There's a lot of things I would not do. So I did not. Keegan, I promise I was not. No. Okay. If we say no, yes, no. Hey, come back here. If we say no, yes, no, if I say all no's, if I say all yeses, we need to see how it works. Okay? So this first time, we're going to take a triangle ABC and we're going to scale factor of 2, but we're going to use a point O that's inside the triangle. Okay? So you can go back to your original triangle. But I'm going to put a point O inside the triangle. It doesn't matter where it's at. Okay? I'm just going to put it in there. And this is now point O. Okay, Nuri, are you watching closely to what I'm doing here?
Yeah, hold on.
Because, okay, you watching? Now I'm going to dilate this triangle with a scale of 2 from this point O. So I'm going to hit transform. I'm going to use a dilation. My center is going to be what?
O.
So I'm going to select O. And it should switch over now. The scale factor is 2. The objects I'm going to use, I'm going to hold the shift key down. I'm going to select A, the side, B, the side, C, that side. No, you do not select O. That's just our center.
Oh my god. We literally dilated from outside the triangle on Delta Knot yesterday.
Okay? So now, this point is A prime. This point is B prime. This point is C prime. So can something be dilated from a point inside the object?
Yes.
So let's see how it works. How did it end up with the triangle where it's located at currently? What is it looking at to determine where that triangle is going to be?
Oh.
Let's say O to A was 5. What would O to A prime be if it's on a scale of 2? 10. O to B is 6. So O to B prime is 12. So O to C is 4. O to C prime is 8. What happens if I move O down? Which direction is my triangle going to go?
It's gonna go opposite.
Why? Let me show you what happens. Let's talk about why that happens. If I take O, notice as I move it closer to AC, hope everybody watch this. As I moved it closer to AC, my triangle went the opposite direction. Why?
Invertation.
Oh, because it's getting close to it.
Because it's getting closer to this. Like, let's say the distance from here to this side is 1. So the distance here has to be
1.
No, 2. Twice that amount. And what happens to the distance between O and B as I move it closer to the side? It gets bigger. So now this becomes bigger. This has to become bigger.
Now drag it outside.
Okay, you're going to drag it outside the circle here in just a minute. Okay, here's how dilations work. Yesterday, some of you figured out the answers for the dilation problem. What did you do, Madison? Y'all were doing it when you dilated by 2 or dilated by 1/2. You divided if it was a fraction. You multiplied if it was a whole number. Because those objects were so far from the origin, when I do a dilation, it has to increase or decrease by that scale amount. Now, We're going to do more of this, but for the remainder of the hour, here's what your responsibilities are. Everybody paying attention. First of all, you need to finish up task 11 by taking a picture and putting that in. Then on your own, I want you to do task 12 and task 13. Okay? You're going to do 12 and 13. 12 is the quadrilateral, and you're doing a scale factor of 4. Now, you might want to keep that quadrilateral small, because if you make it big, you're not going to be able to see the dilation. It's going to be outside the screen.
What's a quadrilateral look like?
It's a 4-sided polygon. On 13, you're going to do a point outside the triangle, and you're going to see what happens. Okay? Monday, listen closely. Listen closely. Monday, we're going to do coordinates, see what dilations do to the coordinates, and we'll finish up dilations. Tuesday and Wednesday, we're going to look at how transformations change triangles. And then Thursday, we're going to review. Next Friday, you'll take the next quiz. You need to be sure you're studying the function notations. That paper that I gave you yesterday. If you weren't here, you need to get with me so I can give you that paper. That's what you need to be studying. Okay? Is everybody clear on what you need to be working on?
Yes, sir.
You've got about 25 minutes, so that should be plenty of time to get this done. Now, don't submit it yet because we're not done. We'll finish up the notes on Monday. Okay?
Okay.
Do we do 14?